Next, a little bit of talk about some next generation solutions that we're working on. As I said, we're working with the French company Midis. They're partners in their experts and innovators in the vibration assisted drilling world. Vibration assisted drilling generally is utilized in metallic layers. It eliminates the pecking that you saw in the previous video. You're able to maintain a more of a near continuous type feed that you'll see. And it's also called micro pecking. So you're creating tiny little chips. So an example, the current process that you saw was with the 500 surface feet and by 8 IPR in carbon, and then 400 by 6 in aluminum. Takes about 12 seconds per hole, what we were viewing in the last video. With the VAD process, utilizing the Midis spindle and a Sharon-Cutwell waypoint drill, we're running the same. We can run the same parameters in carbon, but in the aluminum, even though we're running a slower speed and feed, it's continuous, and there's no pecking, there's no retract, and we can get that down to 3 seconds per hole. So 4 times improvement in throughput. The micro pecking, here's a nice video that kind of shows what is actually going on in the micro pecking in the VAD environment. So while the drill is advancing through the material, it is making some very small oscillations that effectively are creating nice, small, easy to evacuate chips. One thing that we found is that in numerous applications, our P3 drill that we have for aluminum, it pairs very well and stands up very well in VAD environments, in the micropec environment. So our geometry tends to allow the chips to break up very nicely and even more efficiently than other typical geometries. So here's a real world video of what you just saw. So this is about 5 holes drilled. This is about 3/4, 700 thousandths of composite fiber, and then drilling through 1/4 inch of aluminum. And as you can see, there's a slight pause as it's switching to the VAD, to the micropec. But this entire drilling cycle takes about 3 seconds, creating nice little chips that are easy to manage. And again, we've proven that our drills will stand up for life in this same environment. Here's just kind of a quality check of the hole diameter for the process that you just saw, and we get about the same spread of 5/10 of hole tolerance spread, which is the red lines are the hole tolerance. And then the data points here are what we're actually getting. So well within the typical hole tolerance required for an aerospace application. And here is the burr height. Again, burr height exiting in aluminum is a limiting factor. And we got around 800 holes before we limited out on burr height.